ये जो जूम का होगा ना आपके पास, हम तो एक दूसरे उससे लिंक से ज्वाइन कर रहे हैं।
Good morning.
Morning, sir. Welcome to 21st SCA conference. Pleasure to see you.
Likewise.
So we will be joining our session in just a minute of time. Let me check all of them has joined. Good morning. Good afternoon, Janguli, Professor.
Good morning. Thank you very much.
Good morning, Professor Motoko.
Good morning. Hi, Vijay.
So formally, I'm starting the
Hi,
session.
Motoko, how are you?
Namaskar and very good afternoon to all our distinguished guests and delegates from Asia, and a golden morning to our guests and participants from India. I, Dr. Richa Sharma, once again welcome you all in opening session of day 2 of 21st SCA conference hosted by ICSSR New Delhi from 15th to 17th March 2022. It gives me deep satisfaction to inform you that collectively we all have succeeded in making first day of the conference extremely meaningful and educative. Yesterday, total 4 lead papers and 19 outstanding papers were presented across the theme of SCA, entwining science and technology with history, ethics, public policy, economics, social transformation, and also underlying discourses on future Earth with its theory and practice. I am sure this day 2 of the conference will also have outstanding research-based presentation that can contribute to create better world. With these words, now I would like to invite our first keynote speaker, Professor K. VijayRaghavan. Professor K. VijayRaghavan is a principal scientific advisor to the Government of India, and being the PSA, he chairs the Prime Minister's Science, Technology and Innovation Council, whose mandate is to advise the Prime Minister of India on all matters related to science, technology and innovations and monitor implementations. Professor Raghavan has also served as Secretary to the Department of Biotechnology of Government of India. Prior to that, he was the Director of National Center for Biotechnological Sciences of Tata Institute of Fundamental Research and the interim head of the Institute of Stem Cell Biology and Regenerative Medicines. His contribution in sciences as developmental biologist has been recognized widely. He was conferred an honorary Doctor of Science degree by University of Edinburgh in 2011. Not only this, he is awarded with the Prominent Civilian Award Padam Shri in 2013 by Government of India. Sir, indeed, it's an honor to have you on board. Now, I request Professor VijayRaghavan to deliver his keynote address on science, technology, and social science research. Sir.
Thank you very much, Richa Sharma ji. My colleagues here, Motoko KOTANI-san, Jangmu Lee-san, and everyone else over here, Sri Vikram Pola. It's a great pleasure and honor to be here, and I congratulate the Indian Council for Social Science Research in organizing this. My intervention will be very brief, and it takes off from how our perception on how science and technology should go forward has changed during the pandemic and going forward from what it was in 2019. If you had asked us in 2019 and held this meeting in 2019 about what we should do about science and social science, you would have got, I think, a very, very different answer from what you will get today. At that time, disasters which unified the world, in that it was a pandemic, were talked about, but actually hadn't happened in recent times. So people were concentrating on what economic gains they could get, and they were not particularly concerned about biodiversity, the environment, and climate change from an individual perspective. I mean, there were organizations talking about this, but from an individual citizen's perspective, these topics were topics which other people spoke about, and they went about with their lives. Indeed, if you go to the if you go to the documents which big companies such as McKinsey and Bain Consulting and other consulting companies did about what the future would look like in 2050, all of them talked about economic aspects, how emerging economies will become powerful, how the current large economies have to deal with it. It was all about economy. So I will very briefly talk about how we came to a situation where we were concentrating about economic value to be extracted to how we are now coming to a situation where we're talking about sustainable development as the prime focus. Now, the reason we talked about economic value to be extracted lies at its core in about 10,000 years ago when humans domesticated plants and animals. The start of that process resulted in extracting from the earth nutrients to support the growth of plants, and the domestication of animals also required energy and feeding those animals in addition to feeding us. Soon we ran into limitations of how much we could extract from the earth by natural means, and therefore we had to put in fertilizers. Those fertilizers came from nitrite mines in China and South America, and also from large places where bird droppings, guano, were there. So guano and nitrite mines fueled the fertilizers to grow our plants. Soon that ran out. Then there was the invention of the Haber-Bosch process, which got nitrogen from the atmosphere and used that to make ammonia, and from that ammonical fertilizers. And that completely transformed, on one side, agriculture, and the other, the chemical industry, with some very sad consequences. But the transformation of agriculture means today, half the nitrogen in our body comes from the Haber-Bosch process. And this is incredible. The availability of food allowed the booming of human populations, but that resulted in also the growth of various kinds of diseases, and that resulted in the growth of the medical clinical industry. The first industrial revolution resulted in a came from very interestingly, an interesting juxtaposition of fundamental science, the fundamental science of thermodynamics, into applying that to the development of engines of various kinds. So science and technology and medicine came together, and there was a feeling amongst humans that we can do anything. The world is there for us to conquer in every way. And those countries which developed these technologies took off in exponential manners, exploiting the environment, workforce, and developing technology. It seemed like this growth will never end and will go to other countries. Sadly, we know that is not the case. The very science and technology which allowed us to have enough food, which saved billions of lives, and which increased standards of living in some places, turns out to be what in thermodynamics is called a closed system. You can decrease entropy in that closed system, but you're doing that at the cost of increasing entropy, as it were, elsewhere. And this means that the planet was headed for a disaster. Today, we are in a situation where the challenges of climate change, biodiversity, and the environment are what we must address in multiple ways, and disease, as we've seen in the pandemic, going forward. Next point, how did this come about? Because this addresses a question of our responsibility. During evolution, and all life has a common origin and a shared chemistry, humans turned out to be different by a variety of accidents. We could oppose our thumb and forefinger, so we could catch tools and use them. We got the ability for speech and language, and so cultural evolution could go very rapidly. Along with tools and speech, cultural evolution was so fast that it exceeds now biological evolution. We are changing very, very rapidly, and we have what some people have called the extended phenotype. We use our tools, our computers, our phones to extend our ability to reach. And we have moved because of this and because of our ability to engineer nature from being on the planet of the apes to being on the planet of the apps. So this situation is a very difficult situation also, because this has resulted in social change of a kind which we could not envisage even a short while ago. So the combination of our engineering and the combination of our culture and the combination of a cultural revolution has meant that we have moved from being mere survivors on the planet to being those, as Dan Dennett has said, wielding the paintbrush on the canvas on the planet. We own the planet and we are the stewards of the planet. So the planet's future depends on us. So this brings me now to how science and technology and social science are intertwined over here. And I will conclude with that. We need to work in a system of sustainable development where exploitation and plenty in one part of the world, which results in poverty in the other part, is no longer tenable. So the major question for science is, how can we have uniform development without exploitation? And this is a very big challenge. In terms of energy, this means we need to be able to capture energy from the sun, from the wind. Nuclear energy has to be made safe, and energy has to be made available everywhere. Once energy is available at very low cost and very low damage to the environment, a variety of tools will allow distributed development in societies, as distinct from the concentration in huge megapolis which we have seen. This change will naturally happen, and we will go away from rural poverty to rural wealth. This is what will happen in the next 15, 20 years. This will have a major impact on our societies, and therefore social science, economics, history, politics will also have to come together with science and technology. So this is very, very important. Combined with this purpose-oriented research and science and technology, we must not forget that fundamental research in mathematics, chemistry, biology, astronomy are what has sustained us during these few hundred years in very difficult times. Because this learning and scholarship is what allows us to address unexpected problems. Expected problems can be addressed by engineering, but unexpected problems can be addressed only by blue sky research and learning of a kind which explores without immediate purpose. So this combination needs to be done. For this to be done, I will end by saying that we need a new paradigm. So far in human history, knowledge has meant power, and those who have knowledge have had power. Now we must go forward using the very tools we have created to ensure that knowledge is democratized and power is also democratized, and that is the only way we will be able to have a sustainable future. Thank you very much.
Thank you, sir, for this extremely edifying, covering evolution and setting the pathway for multidisciplinary research possibilities in time and space. Moving further, now I would like to invite our second keynote speaker, Professor Kotani Motoko Sensei from Tohoku Daigaku, that is Tohoku University, Japan. Professor Kotani is Executive Vice President of Tohoku University, Professor and Principal Investigator of the WPI Advanced Institute for Material Research and Professor Mathematical Institute, Graduate School of Science at Tohoku University. She specializes in geometry, especially discrete geometry analysis. She received the 25th Saruhashi Prize for her contribution to discrete geometric analysis on crystal lattice. She is an executive member of the Council for Science, Technology and Innovation and the Cabinet Office member of the Science Council of Japan, the former president of the Mathematical Society of Japan, and a member of Board of Governors, Okinawa Institute of Science, Technology, School Corporation. She served as Executive Director of RIKEN. She has been elected as President-elect of ISC, assuming the presidency at the next General Assembly in 2024. Madam, I invite you to give your presentation on advancement of science and technology for sustainable and resilient society that ensure human well-being.
Thank you very much for your kind introduction. Can you hear me? And,
Yes.
and also, can you see my screen?
Yes, ma'am.
So it's now full mode, full screen mode. Okay, so it is my great pleasure and honor to have this opportunity to speak at the 21st Science Council of Asia, which is very important. Also, I'm very honored to speak just after Vijay, who I have known for some time, so my honor. Okay, let me start with self-introduction. So maybe I use a pointer here. Okay, so I'm a mathematician, interested in particularly in geometry and discrete geometrical analysis. So this is me as a researcher. Also, I committed to academic scientific activity. For example, I'm the member of Council of Science of Japan. Science Council of Japan, SCJ, from 2017, which belongs to this Asian Science Council. And also, I'm the member of Mathematical Society of Japan, which belongs to International Mathematical Union and the International Council of Industry and Applied Mathematics. And also this belongs to International Council of Science. So this is my commitment of academic society, but I have two more different roles. In university, I get involved in the management of university and academic institution. I'm executive vice president for research at Tohoku University. And before that, I was executive director of RIKEN, which is the biggest national research and development institute. And also I'm a member of board of governor of Okinawa Institute. This is not a full-time, but a part-time position. So this is my second role. And my third role is I have been working as an executive member of Council for Science, Technology, Innovation and the Cabinet Office. This is advisor to Prime Minister on science and technology, and its mission is policy making on STI. So today I'm gonna talk in this three standing point. So the first presentation is about my role in the science technology policy making as a member of SISTI. And so here my key message is the sogochi in Japanese, which literally means a convergence of knowledge or interdisciplinary science and technology for society. And the society I mean is Society 5.0. So the SISTI is, as I said, the advisory to Prime Minister. And its main mission is to make an action plan for 5 years. And this framework started in 1996. And they make a first plan. And I became the executive member of SISTI around 2014. So I'm involved in this scheme from fourth plan. But my sympathy goes to the fifth plan. First of all, I got involved in this policy making, the fixed-based plan from the beginning, collecting information, discussion, decision making, and to make action plan, promote and monitor and review. And I also participate in designing fixed plan. But this is not the only reason why I get the most sympathy to the fifth plan. The reason why it is a case is the active fourth plan. This plan mainly concerned of advancement of science and technology. And sometimes it's how we make use of science and technology for economical growth. But when we are designing fixed plan, we ask ourselves, So what is science for? It should be society. So first we should discuss the society which we are aiming at. What kind of society we would like to make, and what and how science and technology can contribute to realize that kind of society. So in the fifth plan, we propose the concept of Society 5.0, which I'm going to explain shortly. But this discussion, this conclusion we discuss is toward we obtain this the decision until the last moment of the preparation time of fifth plan. So at the fifth plan, we just make the suggestion or the concept of proposal and suggestion of how we can test our idea in the national project. So what is Society 5.0? As you know, in the history, human society developed from hunting, agriculture, industry, information science. And after that, we would like to have a Society 5.0. At that time, we already discussed about the big data, AI, and the digitalization. We didn't use the word data transformation, but we already start thinking of the effect of digitalization. But at that time, and also, so we discussed how we can make a fruitful interaction between cyberspace and physical space. And also we said the balance between economic growth and sustainability is very important. But around this time, we're still discussing about the economy and science and technology. But then we reached the idea to have a human-centric society. Actually, I don't like this English translation. It's a society for human well-being, where people feel comfort or the happiness in their life and also motivation to life. So this is Society 5.0. And to make it, of course, it's a society for human well-being. So only the science and technology, or one discipline of science and technology or method is not enough. How we feel happiness, how we are motivated. This kind of humanity and social science approach is also very important. So we realize that social transformation through the Sogochi, convergence of knowledge is very important. So we invite all the scientists, not only natural science engineer, but also humanity and social science. This is the Sogochi. And we set 3 pillars: structural transformation, and research capacity, and human resource, the investment of human resource. And we prepare some budget for that. And how we realize the Society 5.0 in the 6th basic plan, we said the transformation in sustainable and resilient society with the society, smart city, and the Moonshot goal, and the creation of knowledge to support the student and young researcher, and etc. So there are many action plans, but I would like to introduce the Moonshot Research and Development Program. So to realize the human well-being by using the science and technology, we set 9 Moonshot goals. I don't read it out, but as you see, it's all the human. How we can we make use of science and technology for human society. This is a 9 goals, and our vision is to make a society in 2050. We make a vision of this society, and to do so, we need some roadmap or milk at 2013. So this project, the goal is 2030, but always looking at the vision of 2050. 2015. So this is the Society 5.0. Now I move into my commitment of academic society. So as I said, I'm the member of Science Council of Japan, which also belongs to this the support of the participation of SCA. And unfortunately, I'm a member of SCJ, but not I don't put too much effort of this activity. So the information I share with you today is borrowed from the SCJ, the international office, and also the Professor Takamura, her support. So I would like to share some information of SCJ. So what is Science Council of Japan, which is a representative organization of Japanese scientists? And from the beginning, it's the it's aiming at the convergence of knowledge for science and technology and society. Therefore, it has a 3 sessions. It's not only physical science and engineer, but life science on humanity and social science. This is a special feature of SCJs. And with this convergence of knowledge, or the participation of all scientific disciplines and all scientific fields, we have several initiatives. One is SDG initiative for climate change. As you know, Japan is very strong physics, natural science, and engineering, material science. Therefore, our contribution would be very strong in the carbon neutral society and energy and device and energy saving materials. So this would be our strong contribution to achieve the climate change. And also another topic is about a pandemic, COVID-19. Their initiative for with and after pandemic, they have a recommendation to the government and society and make a platform and a public forum. These are the action of SCJs. And finally, I have some time for myself so to share my own research. And it's the example. I wouldn't say it's a good example, but this is the research of interdisciplinary research in digital era. I'm a mathematician, but I have opportunity for the collaboration of material science. Although I'm a mathematician, I was the director of AIMR from 2012 to 2019. So M does not stand for mathematics, but the material science. This institute was established under the government national program called WPI, World Premier International Research Center. So the aim of this program is to establish the world-class research institute within Japan. And Tohoku University is very strong in material science. Therefore, we have WPI AIMR at Tohoku University. And so we gather the outstanding researcher in material science from all the disciplines in material science. But this program is very ambitious. They don't allow us to pursue each individual researcher to pursue their own research domain, but to interact with each other to create a new material science. And so we discuss what could be the new material science in digital era. That's why I was invited to be a director of this institute. Mathematics and material science are very strong research field in Japan, but there are very little interaction between two fields. But in digital era, data-driven material design is expected. And the classical material design or production is based on the individual experience and know-how and knowledge. So to use the computational power, you have to translate this vocabulary into computational word, which is the role of mathematics. On the other hand, mathematics is developed to to respond to this request to develop a very complex system of mathematics. So this was a very good timing for these two discipline encounter. And so that was our proposal. But so this is me around 2000. I was very happy sitting at the bottom of the sea without hearing the voice from outside. I was happy because I was trying to create a new mathematics, which is discrete geometrical analysis. And this is the mathematics, new mathematics to bridge discrete and continuum. So for some time, I was very happy to concentrate on mathematics. But then I realized the request from outside, especially from material science. Current material science is to control and observe microstructure, but to create material science, which is a macroscopic feature. So to bridge discrete and continuum is a challenge. So I started the project for the collaboration between mathematics and material science 2008. And so discrete analysis is to describe our world, if our world is continuum, to use the PDE. But we now realize our world is not continuum, but discrete. It's the consist of atom and molecule. So to get to describe this discrete structure in our world, and to make to realize to understand the continuum property is very important. So this kind of new mathematics is very important to understand how material exhibit a good property from this structure, the hierarchical structure, and the mathematics discrete geometrical analysis is very useful. So I started a research project to get the data of structure and the function, but it's not just the gather data to analyze, but the extract the principle to make to understand the structure and the function by using mathematics to give them the universal framework to understand this phenomenon. So this is my project. And at the end, this is my key message. As Vijay already expressed, we now realize the importance science, science for society, policy making, and risk management. And to attack this global agenda, scientists can work best in unison across the border of science discipline, geographic and cultural difference, and diverse thought and perspective, namely the Sogochi and convergence of knowledge. And the science is always explore the frontier, so it cannot be stable. So how we make the dynamism of science is the key, and this is inclusiveness. Inclusiveness is a key for the dynamism of science and how science can contribute our society. So thank you very much for your attention.
Thank you, Sensei, for this extremely interesting and wonderful presentation. The futuristic approach with Sogochi for creating sustainable and resilient society. In fact, Society 5.0 is a noble thought which may be possible by using technology. However, I'm still eager to know what would be law governing the Society of 5.0 and what will determine our relation with AI. With these words, I thank once again to our both speakers for their excellent presentations. And with this, we close our opening ceremony of day 2 and move towards parallel session from this time after half an hour. Thank you all for being part of 21st SCA conference. Konnichiwa. Arigatou gozaimasu.
Well, thank you very much.
We will be meeting again from 11:15 for parallel sessions for theme 5 and 6. Thank you very much.